The first section of Chapter 2 asks the question, what is a function? I suspect you're pretty familiar with functions, but let's make sure that you understand that there's a very specific definition. Let's suppose that we have two sets of numbers. I'm just going to use circles to represent those sets. Let's say we have set A and that we have set B. And inside set A are several numbers. It could be a finite set, it could be an infinite set, but then also inside of set B is another set of numbers. And the definition of a function is pretty specific, and so I want to make sure that we have that. A function, and we'll call that f, a function f is a rule. It's a rule that assigns each element of set A. This is important enough that we need to write down. Which we could call each of the elements in set A, we'll call those x. Okay? It assigns to each element of set A exactly one element or one component or one member of set B. Okay? And oftentimes we call the elements of set B the result of f of x. Okay? So if this is our x, then the function creates a mapping, creates a rule that says, okay, for this element in x, it goes to that element of y, or of f of x. This element of A, it is assigned to that element of B. You can do this. That's not actually a violation of the rule. It is okay for two separate elements of set A to be assigned to the same element of set B. What the rule says is that you cannot have you cannot have an element of set A that's going to two different elements in set B, like this. No, can't do that. That would not be a function. But it is okay if two different elements in A, because each element of set A is assigned to exactly one element of set B. Okay. Now there's some other names that we use for set A and set B. We call this, the domain, or the input, or the independent variable, or what you are most comfortable with is just calling this x. And then the set that the function maps to is called the range, or the output, or the dependent. It depends. The result in set B depends on what you started with in set A. And this is called f of x, the result of the function. Let me go with an example that you're really familiar with. Previously we've seen y equals x squared. The only difference is now, instead of saying y equals x squared, we're going to say f of x equals x squared. And I'll show you that the reason we can call this a function now is because this function, x squares, assigns each element of the input, each element of x, to exactly one element of the range, or one element of f of x. You've seen this before. You've seen how we can set up a table, and you have, this is the input, this is the output, or the domain, and the range. Let's just go with -3 to +3. And the result of the function is x squared, which is going to be 9, 4, 1, 0, 1, 4, 9. Now you see what I was talking about? it is perfectly fine if two different elements of the domain, two different elements of the input are mapped to or are assigned to the same element in the function. Okay, so -3 is is connected to or mapped to 9, and +3 is connected to or mapped to 9. Now, with this function f of x equals x squared, what this says is whatever the input value is, if the value is -3, then do this. Let me show you. So if the input is 5, then this is going to be 5 squared, which you know is 25. If the input was a, that would be a squared. If what we're putting into this is a plus h, well, then it's a plus h squared, which is a squared plus 2ah plus h squared. So whatever is in these parentheses is what is operated on by this function x squared. All right? Well, let's continue on with another example and try and help you understand a couple of other properties of functions. Let's do what your book refers to as evaluating functions. Evaluating functions just means go ahead, run the input value through the function, and let's go with a function like this. Let's say that f of x, and this will be something that you've seen before as we've worked through previous sections with, let's say, quadratics. Let's go 3x squared minus 2x plus 5. Well, what is the result of this function if our input is 2? When x is 2, what is the result in the range that 2 is mapped against? So we square, and then we multiply by 2 and add 5. And so in this case, that's going to be 4 times 3 is 12 minus 4 plus 5, and that's going to be 13. But again, what this function says is whatever the input is, do this. Square it, multiply it by 3, and then subtract twice the input and then add 5. So if I again said a plus h, this would be 3 times a plus h squared minus 2a plus h plus 5, and we would have to simplify that 3, and what we saw from there at the bottom of the previous column, a plus h squared is a squared plus 2ah plus h squared minus 2a minus 2h. Catch that? The minus 2 times a minus 2 times h. Make sure you have minus on both of those. Plus 5. Now if we simplify this, we're going to get 3a squared. By simplifying, we have to distribute first and then collect like terms. So we'll distribute 6ah plus 3h squared, and then we'll just write this down for completeness. And now we collect like terms. Are there any? Well, we got a squared, h squared, a. Nope. We're done. So we can't simplify that because there are no combination of variables that are exactly the same.